Okay, thanks Trevor, and thanks everyone for coming along this evening. This evening I want to talk to you about, has red clover a role on your farm? And really very much continuing on from where we've left off, has red clover a role in economically supporting higher levels of average daily gain that can support and help us achieve systems of reduced slaughter age or age at first calving? And we want to do this, from a low level of fertiliser use in our farm systems. So just to begin, I'm going to give a little bit of a context to my background and why I'm interested in red clover. I'm a livestock systems researcher, and my work to date has really focused on identifying animal genetics, grassland management and different nutritional strategies that can help achieve highly profitable, high output systems that can support reduced ages of slaughter. And we've done a lot of that through genetics and feeding of our grass diets. But really, when we go back and look at the figures, we can see that there's a big opportunity in our farm systems to reduce the level of nitrogen that we've been using. And we're really interested in, reducing the level of chemical nitrogen that we bring into grower crops. We want to reduce the amount of concentrate which contain nitrogen that come onto our farms. But the big one we want to do is to maximise animal performance. And really, we're interested in technologies that will allow us, satisfy those three needs. And the use of legumes, such as red and white clover, is one of them. And it's going to bring on the back of it, beef production system benefits, driven by economics and environmental efficiency. But I suppose, what is the role of legumes, in our beef production systems? And the role of them, can either be predominantly as graze systems, if we're in regard to our white clover, or with red clover, it's very much in a conservation system, and helping achieve, high animal performance over those winter months. And the reason we're interested in forage legumes such as red and white clover is because of their ability to biologically fix atmospheric nitrogen and make it plant-ready available in the soil. And on the back of that, we can reduce our dependence on chemical nitrogen fertiliser in our farm systems if we can achieve that. And if we can, use legumes to support low nitrogen systems, we can get higher herbage production, we can improve the sward quality throughout the year, and on the back of those, we can achieve higher levels of animal performance. But I suppose the first place that we should be focusing is on the grazing sward, which is, the most permanent basis of animals' diet over their lifetime, and the role of white clover, within those grazing swards is massive. But we should look at the indoor winter periods where we're feeding our most expensive diets to our animals, and that's where the role of red clover comes in. To see, can we shorten, that finishing period, or can we get higher average daily gains over that first winter and achieve, better lifetime performance? And there's lots of positives of red clover. And if we look at that ability to biologically fix nitrogen, we know that red clover can achieve, between 200 to 300 kilograms of nitrogen fixation per hectare. So a very, very high level of nitrogen fixation. And, in silage systems, that can mean the elimination of chemical nitrogen application in those systems. And we know from numerous studies, in Ireland and across Europe, that there's a very high dry matter production potential from our red clover silage swards. Greater than 15 tonne, across a 3 to 4 harvest year, and longer in certain cases. And we know from forage legumes, and especially red clover, that they have a very high dry matter intake potential. And on the back of that higher dry matter intake potential, we can see increased levels of animal performance attainable. But I suppose on the back of all those positives, there could be some limitations to a red clover system. And I suppose the big one in an Irish scenario is the lack of flexibility that we have with our red clover swards. We often in our farm systems, we have a very much blended approach to grazing, maybe one cut silage system, whereas with our red clover, because of the plant structural differences, it is more typically suited to silage harvest production and not animal grazing. So that limitation, or tying our hands a little bit in having the option of grazing a paddock, can deter us from incorporating clover into the system. Or if we do choose to go ahead and sow red clover on that, and do expose it to frequent animal grazing, we can drastically reduce the persistency and the economic advantage of that red clover sward. And typically, in comparison to our grass plant, or perennial ryegrass plant, which can, remain highly productive for in excess of 10 years in the sward, red clover is typically of a shorter persistence, and maybe on a 3 to 4 year cycle, in your typical farm system. And as well as that shorter persistence, there probably is a requirement there to offer a 4-year break in between red clover sowings. And that is to break down the build-up of soil-borne pests, as well as the spread of fungal diseases that may affect the crop. And I suppose in some of our silage systems, especially at low dry matters, we're dealing with a crop that's potentially high in nitrates. We can come across difficulties in ensiling, if we do not get sufficient wilting conditions or have a very poor level of grass within the sward. But I suppose before all of that, we have to establish the crop. And we're very lucky to have Martin Conley here this evening, who has established red clover into his farm system, and we'll hear from Martin as to why he's chosen red clover, but some of the agronomy and the choice of his paddocks, the methods that he's used, and a little bit of his experience. But I suppose in Ireland at the moment we've no recommended list to identify suitable red clover varieties for use in our own environment. And we strongly rely on the UK recommended list to choose appropriate varieties that offer very stable yields of dry matter and that can persist over multiple harvest years. And I suppose when we're picking a variety very similar to grass, we might pick heading dates that will indicate when those crops are going to flower, when we want to see a drop off in their quality, and when they need to be harvested. And we also have some ploidy differences there with diploid and tetraploid varieties and differences between those in terms of their persistence. But I suppose one of the big ones is when we sow it and the type of seedbed we sow it into. And with all clover crops, look, the spring is the most reliable time. And it's the most reliable time in terms of soil moisture, soil temperature, but the big one is to get the post-management practices put in place, such as spraying, the cleaning off of the herbage at a low cover to allow light penetrate the sward and increase the proportion of clover. And as I said, it should be grown in rotation. But I think we're very fortunate enough, if we sow our red clover with high quality perennial ryegrasses, or even undersow with some white clover, that when the red clover does burn out, which it will, be it 3 or 4 years in, that we have a very productive sward of perennial ryegrass and potentially white clover that can remain productive, in excess of 10 years and write off that cost for reseeding. But I suppose we have to understand the growth habit differences in our plants to understand their differences in management between red clover and white clover. If we look at a red clover plant, we can see it's a very tall erect plant with a very deep taproot structure on it. But it's solitary, it grows from a solitary growing point, and that means that it's more prone to damage, it's more exposed, and when that growing point gets damaged, that plant is gone. Whereas if we look at a white clover plant, that is a stoloniferous growth habit which creeps along the base of the sward, putting down multiple growing points and can regenerate from those. So it's more protected in the sward and can regenerate itself somewhat. So here we've a drone footage from some of our, what I thought was a good clover paddock until we put up a drone and saw what lied in the middle. And we can see, under the same management in that whole environment, that there is, certain conditions that really hamper the persistence of red clover. So we can see in the headlands of the paddock where there's a lot of, machinery passes, heavy trailers, a lot of turning of tractors, etc., and how that's damaging the clover plant and how we see it die out of the sward after a very, very short period of time. And I suppose if we look to the middle of the paddock, and only from chatting to different people, we found out that there was a ditch previously in the middle of the field, and that was removed. Certain clay disturbance, clay brought into the site, and we have to look at, was there stem mealworm or some other parasite or pest, in the soil that has caused, the clover plant to burn out of that area. I'm not sure, but it just highlights, the more complex management that can be associated with red clover, and the probably more diligent site choice that we have to put in place when picking a paddock to sow red clover in. But I suppose, how do we get the best out of our clover crops? it is really best suited to a multi-cut silage system. And really in a multi-cut silage system, to get the best right out of clover, you have to take that first cut very early on. And we look at some of the benefits as to why we want to get that first cut removed. And the big one is we allow light into the sward to benefit our second and third cuts. And also by getting that first cut in earlier, we pull forward that final cut, and we ensure that we're bringing our third cut forward, pulling it back, trying to avoid making late cut silage beyond early September, when we're going to have lower dry matters, poorer wilting, and poorer preservation conditions for our silage. But we want infrequent cuts that allow about 6 to 8 weeks between cutting intervals. And the reason we want to do that, if we look at the picture, we can see the big canopy that's there on the red clover plant. And that canopy intercepts sunlight, and it can take that sunlight and create additional carbohydrates which are stored in the residual and the taproot of the plant, or the crown. And it's that carbohydrate reserve that will help improve the persistence of the plant and fuel the regrowth after the harvesting of that crop. So if we don't allow sufficient time between harvest cuts, we don't fully replenish those carbohydrate reserves. And if we cut, at maybe a month interval, we can deplete and run down those reserves in the plant and reduce the lifetime persistency. Some farmers you hear saying, it's great to let the crop go to flower. It's probably not letting it go to flower, it's not really regenerating that way. It's just that you're allowing enough time between the harvest to replenish the full reserves prior to cutting. But I suppose one thing, and Martin touched on it just chatting to him last week, is about the wilting conditions of the clover crop. We need a wilt, but you have to manage it very quickly to avoid leaf shatter when tedding or raking in the crop. But I suppose you have to trust in the clover plant and trust in its potential. And it's only when we really pull nitrogen out of our red clover systems that we see the true benefits of it. And with the removal of chemical nitrogen applications, we really see an increase in the proportion of red clover in the sward. And we know that at higher clover proportions, we're fixing more nitrogen. And on the back of fixing more nitrogen, we're growing more tons dry matter. And that's really important. So if we spread chemical nitrogen, we suppress the percentage of red clover, we get lower biological nitrogen fixation, and we reduce dry matter production. So really, less is often more in the scenario for red clover. And if we look at some plot work from Teagasc Grange, completed by Dan Clavin, and this is over a 6-year period under a kind of a 4-cut simulated grazing system, we can see that the perennial ryegrass and red clover under a 0 chemical nitrogen application system could support the same level of dry matter production to a perennial ryegrass receiving in excess of 400 kilos of chemical nitrogen. So that's a massive, massive ability, and gives us great confidence in our red clover crop. So we're interested in incorporating red clover into our dairy beef system as a component study. And this is the performance from our 2 to 3 year old red clover swards over the last year. We can see that those swards in 2022 produced in excess of 19 tonnes dry matter of between 3 silage cuts and 1 aftermath grazing. But what we can see is the clover proportion across the year is plotted, and we can see from the first cut in May how we increased the red clover percentage up from 38%. By removing that herbage and allowing light down into the base of the sward, we get that clover percentage up to 87% for the second cut and 88% for the third cut silages. So that just shows the importance of light, the importance of that early cut. And if we delay that cut any later, we're pushing that third cut out into late September and really making questionable silage, which isn't cheap to do. So I suppose we have to look at, how well does this silage feed? And look, we know all the studies nearly indicate that red clover grass silage has an increased dry matter intake potential. And on the back of that, we can, maintain or even improve animal performance. And it's the chemical and morphological characteristics of the red clover plant that support this higher level of intake and subsequent performance. But just one thing, I suppose I've had a lot of organic producers in the last week sending on silage analysis and different reports, and probably, citing that the feed reports are probably underestimating the feed potential of our red clover silages using some of our crude feed values that we use. And this happens because the way the fibres break down in the red clover plant, as well as the way the protein breaks down. And if we talk and look at the digestibility of the plant, typically red clover silages have a lower digestibility. And that makes sense. If you go back and think of the plant, it's a very tall, erect plant. It takes a lot of fibre to support that structure. But it's the type of fibre that is present in it. And the fibre that is present has a higher level of completely indigestible fibre. But the fibre that is digestible breaks down at a much faster rate. And it's this faster rate of breakdown of the fibres and a reduced particle size in the rumen that causes it to pass through the animal quicker, reducing rumen fill and facilitating that higher intake potential of the animal. And when we look at our protein, so our dietary nitrogen is an indirect measure of our crude protein values, and typically red clover crops are typically higher in this crude protein level, but really the type of protein that is present is what is really important. And the type of protein that is present in red clover goes through certain forms of protection, and that protection can prevent this protein from degrading either in silage bales or in the pit, but most importantly in the rumen of the animal. We don't see this protein broken down in the rumen. We see more of it getting through to the small intestine, where we get greater levels of absorption and diversion into the production of extra animal protein or growth. So sometimes as well from our silage analysis, the crude protein values may appear low, but we must take into account that these are zero nitrogen systems, so we're not, we may be underestimating the true level of protein that is available in some instances. And we can see that from our feed analysis from Teagasc Grange. If we look at our first cut silage and look at the red clover silage, we can see it's coming back at about 12.5% crude protein. Whereas with our perennial ryegrass cut the same day, but managed under a conventional level of chemical nitrogen, we can see that that's a 14% crude protein crop. And that's at a 37% red clover percentage. Whereas if we go forward into our second cut silage, we can see, again, as you'd expect, with 88% red clover, we see a decline in the digestibility. But we see an increase in the crude protein value of that crop on the back of increased levels of red clover. So look, our work going forward is trying to look, we're feeding back these silages in a study this winter and looking at what is the animal response in terms of intake, growth and subsequent growth over the second grazing season. But I suppose, what does it mean to the animal? And red clover diets will increase dry matter intake of our animals, and that even despite often lower digestibility. And if we look to some of the last work that was completed on this island on red clover silages was in 1982, and they found that red clover diets over the first winter of dairy beef weanings at the same digestibility to the grass silage could support an additional 300 grams of average daily gain per day. So that is a massive, massive difference. Whereas if we look at our finishing diet, and at a 12% lower digestibility, red clover could support higher intakes and, slightly better or a very similar average daily gain in our finishing animal. But really what we should be focusing on is having high digestibility red clover crops to capitalise on all of the advantages of red clover. So look, we have a research project in place this year, and we're trying to see where is the best response from a red clover silage. Not all our silage is going to be red clover, so do we get a better response from our weanling or from the finishing animal? And I suppose one thing we have to look at is, does it pay us? And Peter Doyle has completed some very thorough feed cost analysis where he's compared a two-cut conventional grass silage system on a per bale basis to a three-cut red clover silage system. And if we just take a direct comparison of the two-cut grass silage system to a 3-cut red clover system using a blend of animal slurry and imported 0730 as the source of nutrition, we could see straight away that there was an economic advantage of €3.30 on a per bale basis. But where we improve the use of our animal slurries and go to an all slurry system, that economic advantage of the 3-cut sided red clover system increases up to €6.30 per bale. And if we could improve the lifespan of that red clover sward up a further 2 years, from 4 years up to 6 years, that could bring that economic advantage of the red clover silage bale up to €8.40 ahead of a grass silage bale. And if we were to see an increase of 25% in fertiliser price, we'd see that economic advantage of red clover silage, increase in excess of €10. However, if we saw a decrease in our chemical nitrogen prices, we'd see, the attractiveness of red clover reduce somewhat in comparison to a grass-only system. So just looking at some of the current research that we have ongoing at Teagasc Grange, be it on the dairy beef side or with Peter on the suckler side, we're interested in agronomy. We're interested in identifying the best varieties for use in Ireland. And we're interested in the role of nitrogen application in our red clover systems. We're looking at dry matter production and the stability of that over time. We're looking at the feed value, what it means to intake, the performance, the conversion efficiency of our animals. And then on a farm system basis, what does it do to the nitrogen balance? Is it economical? What does it mean to the environment? And what's the relative feed cost of red clover to other feedstuffs? So just to conclude, look, there's opportunity to reduce our dependence on chemical aid, and that's going to be facilitated by red and white clovers. And they have the ability, to fix massive levels of chemical nitrogen. And look, there is the potential for improved animal performance, but I suppose that our management will largely dictate if this is realised on commercial farms. And I suppose we're going to hear from Martin about the suitability of red clover, in his bull beef production system where average daily gain is everything, and to displace expensive concentrate out of his diet. What role has red clover, got in helping him support his system objectives? And look, there is going to be increased levels of management. It's primarily focused towards silage production. It's probably more suited to your drier soils that have greater flexibility, but it can result in a lower cost of production. But that cost advantage is dependent on the yield you can get, how long you can sustain that yield over how many years it will persist for, and fertiliser price will also dictate the attractiveness of it. So that's my presentation for this evening. If you have any questions, you can get in contact with myself, or if you have harder questions, you can get in contact with Peter Doyle, and look, we'll try and answer any of those questions this evening.